Efficiency improves inside organizations all the time. Factories run faster, automation spreads, errors fall. Yet output often does not change. Production stays level. Shipments remain steady. The gain exists, but it remains internal. But in practice, that increase often fails to appear. Internal productivity metrics improve, cycle times shorten, and error rates fall. Yet shipments, product availability, or revenue remain largely unchanged. From the outside, the system looks static despite measurable internal gains. A common explanation points to demand. If customers are not buying more, additional output will not materialize. Another interpretation focuses on managerial caution. Organizations may avoid expansion due to uncertainty, cost pressures, or risk exposure. These explanations emphasize external conditions or decision-making behavior. What they overlook is structural absorption. Efficiency rarely moves straight into visible output. Instead, it enters a system already shaped by constraints, priorities, and bottlenecks. The gain is first redistributed internally, reorganizing how work is performed before it alters what is observed externally. The first mechanism is capacity reallocation. When efficiency improves, time and resources are freed. Workers complete tasks more quickly. Machines idle less. Software reduces manual coordination. Yet, these freed resources rarely produce immediate additional units. They are typically redirected toward tasks that were previously compressed, delayed, or overlooked. In manufacturing environments, faster assembly often exposes hidden work upstream. Teams may invest extra time in maintenance, calibration, or inspection. Quality checks become more thorough, and rework declines. Output volume remains stable, but reliability improves. Efficiency is converted into consistency rather than expansion. This reflects how organizations balance multiple objectives. Output competes with quality, predictability, safety, and cost control. When efficiency appears, it is frequently absorbed into these competing priorities. Over time, this reallocation accumulates as smoother workflows, lower defect rates, and reduced variability. Only after these adjustments stabilize does excess capacity begin to surface as visible production. The second mechanism is bottleneck shifting. Systems are constrained not by their average performance but by their narrowest limitation. Improving one stage often relocates the constraint rather than removing it. As a result, overall throughput remains governed by a different component. In consumer electronic supply chains, faster assembly may shift the limiting factor to component availability, inspection capacity, or shipping throughput. The improvement changes where the system slows down, but total output continues to reflect the new bottleneck. Externally, the system appears unchanged even though internal efficiency has advanced. This movement of constraints creates a gradual path for change. Each improvement reveals another limitation that must be addressed. Over years, successive adjustments expand system capacity. At any single moment, however, gains seem muted because they are offset by newly visible constraints. The third mechanism involves buffering and demand absorption. Most systems maintain slack to manage uncertainty, fluctuations, and risk. Efficiency gains frequently expand this slack before they increase output. The system becomes more resilient rather than more productive in an immediately visible sense. In logistics networks, route optimization may shorten travel times and reduce fuel usage. Instead of increasing shipment volume right away, companies may use the improvement to stabilize delivery windows, absorb peak demand, or reduce delays. The efficiency strengthens service reliability. Volume remains constant, but performance becomes more predictable. A similar pattern appears in knowledge work. Automation that saves time is often redirected into planning, experimentation, or coordination. These activities do not instantly produce measurable output, yet they enhance adaptability and scalability. Efficiency accumulates as optionality, expanding what the organization can handle in the future. Across these mechanisms, efficiency enters as potential rather than production. It interacts with constraints, priorities, and uncertainty, gradually reshaping workflows and redistributing effort. Visible output increases only after these internal adjustments accumulate and stabilize. This time dimension explains the perceived disconnect between efficiency improvements and results. Internal indicators may show faster processes and fewer errors, while external metrics remain flat. The system is absorbing the gain, converting it into reliability, flexibility, and reduced friction. These changes unfold quietly before appearing as growth. Historical patterns illustrate this gradual accumulation. In manufacturing, decades of incremental process improvements reduced defects and variability long before they produced dramatic increases in output. The expansion of capacity emerged from layered adjustments rather than isolated breakthroughs. Digital infrastructure reflects the same dynamic. Improvements in computing efficiency did not immediately increase output. Instead, organizations expanded redundancy, experimentation, and service complexity. Over time, this absorbed efficiency enabled new applications and business models, demonstrating how structural integration precedes visible scale. Understanding efficiency as absorbed capacity reframes expectations. Short-term stagnation does not necessarily indicate ineffective improvement. Early gains often appear as smoother coordination, reduced risk, and improved reliability. These internal shifts create the conditions for expansion without immediately altering observable production. This perspective highlights how meaningful change accumulates slowly. Systems consist of interconnected layers governed by shifting constraints. Efficiency must move through these layers, redistributing pressure and reshaping priorities before altering external outcomes. Each layer absorbs part of the gain, gradually expanding what the system can sustain. Over time, accumulated adjustments become visible. Bottlenecks ease, buffers stabilize, and reallocated capacity begins to exceed internal needs. At that point, output expansion appears less abrupt and more continuous. What seemed like delay reflects a process of integration unfolding beneath the surface. Efficiency gains therefore resemble pressure moving through a structure. They reinforce weak points, adjust pathways, and expand tolerance for higher throughput. The visible increase in output is not the immediate result of improvement, but the later expression of these structural changes. This pattern extends beyond production environments. Improvements in infrastructure, education, or healthcare often accumulate as capability before appearing as measurable outcomes. The lag reflects how complex systems incorporate change, redistributing gains across stability, resilience, and adaptability before converting them into scale. As efficiency continues to accumulate, the boundary between absorbed potential and visible output gradually dissolves. Structures adapt, constraints loosen, and the system's capacity expands. Yet, this transition rarely coincides with the moment efficiency improves. It reflects an ongoing process of redistribution and stabilization unfolding across time.